Okay.
Okay, it's 11 a.m. so we'll kick off. People will join, but this is just the introductory session. So thank you everyone for joining this morning's webinar. My name is Gráinne Doolan and I'm the Communications Coordinator within Demeter. So I'm going to take you through our agenda for this morning. So we're starting off with welcome and introduction. Our first speaker then is Kevin Doolan. Kevin is the Demeter Project Coordinator and Director of Walton Institute here in Ireland. And Kevin is going to give you an overview of Demeter, talk about our objectives, give you an overview of our technical ecosystem, and also talk about the open call process, looking at this Open Call 1 develop. Our next speaker then is Dave Hearn, and Dave looks after the multi-actor approach within Demeter, ensuring that all our stakeholder needs are met and understood. And Dave is going to give you an overview of the 5 specific challenges which were addressed by this Open Call 1. Then we're going to hear from the most important speakers, which are Open Call winners, and they're going to each give you a 5-minute presentation talking about their solution, how they integrated within Demeter, and their next steps as organizations. We'll take time then for questions and answers. And then our final speaker is Jorge Lopez of Demeter, who is our exploitation manager, and he's going to talk about the next steps if you're interested in learning more about Demeter. And we'll have a very brief then wrap up and conclusion. Just to let you know that this session is being recorded. So we will share the recording with you afterwards and post it on our YouTube channel. And we'll also give you a copy of the slides from this morning's webinar as well. In terms of the question and answer session, so as I mentioned, we will have dedicated time after all the speakers so you can ask your questions. So please post them in the Q&A function and we will take time to address each of those as well. And then finally, if you'd like to learn more about Demeter and keep in touch, please follow us on social media. We're on Twitter, LinkedIn, Facebook, YouTube, and then we also have a dedicated quarterly newsletter where we share information about the project, our activities, and how we're achieving our objectives. So I'll share a link to that in the chat as well. So here's our website. If you have any more queries, feel free to email us. And without further ado, I'll pass you over to Kevin Doolan, who is the Demeter Project Coordinator.
Thanks, Gráinne. Hi, everybody. Sure. Hi, so yeah, as Gráinne said, my name is Kevin Doolan, and I am the Executive Director of the Walton Institute in the Southeast Technological University, and I'm the coordinator of the Demeter project. So I've just a few minutes to take you through what Demeter is about and to look a little bit at some of our architecture, talk a little bit about the we're presenting on here today. So it was funded under the ICT 08 2019 under Horizon 2020. And we have a contribution from the European Union of 15 million euro and total project budget 17.5 million euro. We have a 4-year duration. We were originally 3.5 years, but we extended recently up to the end of August 2023. And we have 60 different partners. Demeter is all about enabling interoperability, particularly at a data level from farm to fork. And to verify that, then we have a number of different use cases within the project, covering a number of clusters like arable crops, precision farming, fruit and vegetables, livestock, and supply chain. In terms of the scale of and its pilots, we cover around 318,000 hectares of land, almost 6,000 farmers, 29,000 devices and sensors across 80 sites. And we have a very strong global outreach, important for the participants in our open calls, because within the project, we've, in particular, the World Farmers Organization, who are very strong supporters of the project and help us disseminate to a potential audience of almost 1.5 billion people. Everything we do in Demeter, of course, is driven by our multi-actor approach, which I believe will be touched on a little bit later, but essentially it's involving the end users and farmers, technology providers and so on from the project outset in terms of setting pilots or providing added value in terms of what they're trying to achieve. We have a number of core objectives within Demeter, and just to briefly touch on them, firstly, we're looking at analysing and adopting and enhancing different information models within the agri-food sector. And we do this within what we call the Demeter AIM, the agricultural information. If people are interested in AIM, you can contact us. We have other webinar material particularly devoted to AIM. And actually, I'll be presenting it later in Data Week this afternoon. We're also building knowledge exchange mechanisms through our interoperability space for agriculture. We are empowering the farmers, particularly to let them control their data in the data food chain. We are establishing benchmarks for best technical solutions relative to user needs. We're also trying to reverse the relationship with suppliers so that we ensure that all our solutions are very much user-oriented. And of course, none of this would make any sense if we didn't try and demonstrate the real-world impact of the technology and architecture and the multi-actor approach within the project. And that's done through both through our pilots, but also through these open call projects, which I'm delighted to see presenting here today. This is just very quickly shows a map of our pilots and where they're spread across Europe. You can find details on the link there on the website, and I presume we'll make these slides available later on. But you can get all our details there. So I just want to touch briefly on the architecture aspects of Demeter as well. And what I'm showing on the screen here is essentially the heart of the system, which we call the Demeter Enabler Hub. And this hub provides multiple different functionalities. So first of all, we've got our Demeter Dashboard. This is the sole entry point into the Demeter technical ecosystem for Demeter developers and for other stakeholders. And the hub makes available two interaction spaces. So we've got the stakeholder open collaboration space, and we have our agricultural interoperability space, which I'll mention in just a couple of minutes. And these spaces are available to the human users of Demeter. The hub also enables Demeter end users like farmers, agronomists, cooperatives, and so on, to be able to discover any Demeter-enabled applications, and then offers them user-friendly interfaces to be able to access, understand, and control the data that's captured or inferred within Demeter. They can also perform administrative tasks over their own Demeter accounts. They can get an overview of the usage of their personal data by external stakeholders and so on. We also use it in Demeter to allow stakeholders to provide their feedback regarding their perceived experience and the added value of the Demeter-enabled commodities that they used. So within this ecosystem, interested developers and stakeholders can register their offered technical capabilities and resources, and they act as what we call Demeter providers. And then we have Demeter consumers, who can browse the Demeter Enabler Hub to discover different capabilities and resources that match their criteria for whatever solution they're trying to build. The hub also verifies identities and provides support necessary for establishing direct, secure communication channels, for example, amongst consumers and providers. And then within the hub, we make what we call our enablers, which is the underlying technology. We make these available through the hub, and these are either services developed by Demeter itself or resources offered by external stakeholders. So, for example, third-party service providers or platform providers. It also connects the resources to our agricultural interoperability space, which can support team-ups to create combinations of tools and services for farmers, and to the stakeholder open collaboration space where we support knowledge sharing. And this allows service discovery from, I suppose, a functional or feature point of view, and can be used during the resolution of any challenges that are launched through our co-creation mechanisms. And of course, critical to this is of the multi-actor approach within Demeter, where we support the co-creation of needs, the co-generation of solutions, co-shared responsibility for efficient deployments, and co-organized support for optimal adoption. So as I mentioned already, our architecture is focused around a series of enabling technologies, or Demeter Enablers, as we call them. And there's basically two types, as I'm showing here on the slide. We've got core enablers and advanced enablers. Core enablers are mandatory for any interested stakeholder that wants to expose or share its own resources or use the resources made available in the hub. And these core enablers support things like communication and networking, semantic and functional interoperability, security protection, and they provide a client interface for the Demeter hub as well. And then the Demeter are functional, they're discoverable and they're accessible within our hub. And they provide, I suppose, some of the more intelligent services like data and knowledge enablers, decision support and performance monitoring enablers, and integrated delivery enablers as well. So quite a large selection of technologies here. But today we're here to talk about the output of the open call, our first open call, which is called Develop. And essentially, there's four main reasons for us launching this open call and proposing it in the first place. The first is to be able to attract SMEs and startups into the Demeter ecosystem. As is the case with any large-scale European project like this, the value of developing technology can only go so far, but we really need to get external entities and users to use the system and engage with the ecosystem to verify or not the value of what we're producing. The call also supports and funds integration and interoperability activities, so showing how technologies developed within Demeter can integrate and interoperate with let's say, external technologies. And this allows us then to expand the offering of Demeter. And finally, it also supports the co-creation of user needs and solution creation. And that's it. Grania, in a nutshell. Thanks, everybody. We can take questions, I guess, at the end of the session.
Great. Thanks very much for that, Kevin. So now I'm going to hand you over to Dave Hearn, who's going to talk about the specific open call challenges, and he will introduce each of the open call winners before they speak. Thanks, Dave.
Perfect. Thank you, Grania, and thanks, Kevin, for the introduction to Demeter. So hi, everyone. My name is Dave Hearn, and I am part of the multi-actor approach team within Demeter. And within Walton, I am a user experience researcher and engineer. So within Demeter, what we're trying to do is change the narrative from designing for farmers to designing with farmers. And this is where our co-creation comes into action. So we start with interviews, surveys, and then workshops to generate ideas and solutions to problems that may be seen on farms or by other stakeholders. So this multi-actor approach or co-creation holds true going through to all our open call winners, and even before they were selected to when we announced the topics. So each topic was identified within the consortium through a co-creation method. Again, we tried to figure out what problems we need to solve outside of what we already specified within Demeter. But these topics also needed to hold true for the Demeter objectives that Kevin went through earlier. So overall, we have 5 topics: soil workability and humidity monitoring, interoperable geotag photo app, ISO bus enabler, blockchain-based solutions for agricultural applications, and the Demeter business process integration BPM. I'll go through each one of these in a little more detail. So the challenge from topic 1 is soil workability or soil humidity. So to be able to enter a field to do work, machines need to find ground strong enough to support the weight of them. And for humidity, predict possibility of work in fields and enable better planting, application, and harvest, but also reduce the cost of machinery. Topic 2 was to create an interoperable geotag photo app. This is very important at the moment with the new CAP. So farmers need to provide certain information to Paying agencies are public administrations for several reasons. So for CAP funds, there may be requests like BPS, IACs, generate requests and send them to an app or to a farmer to act on. And CAP post 2020 forces paying agencies to monitor the entire territory for agro-environmental and CAP performance. So where Sentinel images are not enough, geotag photos are now being identified as equivalent data to satellite data. So if you cannot get an image from Sentinel, a farmer will be requested to take a geotag photo. EU member states are most certainly going to request from farmers geotag photos with specific metadata to conclude the monitoring phase for the whole territory, including small parcels, crops, different anomalies on parcels, scrub, etc., that can't be identified or are difficult to identify by satellite images. Topic 3, ISO bus enabler. So interoperability is one of the key challenges in agriculture, where interconnection between heterogeneous hardware and software systems play a key role. Farmers are using machinery coming from different vendors with their internal systems from another vendor or multiple vendors covering different processes. The goal is to enable different protocols and standards in the agri-food domain, talk to each other by enabling machinery to interoperate with other machines and platforms. And this is handled by the ISO bus protocol. Blockchain-based solutions then is topic 4, this challenge. So there is a need for traceability in the agricultural domain, from simple supply chain monitoring, procurement tracking, crop and food production, insurance, land registration, and payment of services. The main challenge of the existing blockchain-based implementations is that they still suffer from the traditional challenges like poor infrastructure, failure of interoperability, and easily integrate with different farm management, farm management information systems or different technologies existing on a farm. And then our final challenge, and I'll stop talking and introduce our winners, is the business process integration. So farm management implies using a range of data sources and creating actions based on the analysis of the collected data. A coherent and streamlined creation of actions and monitoring of their execution is of great importance to agricultural companies. There is a need to ensure efficient utilization of the workforce and the company assets while contributing positively to overall success of the company. Ensure efficient sharing of data between business processes in real time with the business processes integration. And they are all the challenges. And again, if there's any questions, there is a Q&A tab. So please click on that and type your questions in there. Okay, so introducing our winners. We're going to go through them topic by topic. The first topic we're going to look at is soil workability and humidity monitoring. And our first speaker is Federico from Primo Principio. Federico will talk about their solution Y for Agri, Soil Workability DSS, which is data-driven service for smart agriculture. It is a suite of modeling tools developed as web services and offers the final users as a SaaS product or software as a service. So Federico, I will pass over to you.
Good morning, Dave. I'm sharing my screen.
Yes. Thank you.
Okay, so I will present in these 5 minutes our solution. Sorry if I will be too fast, but otherwise I will be not able to stay in your time. So basically, you presented very well the challenge. The challenge is to help farmers to assess the workability time windows and also the trafficability time windows. The Y4Agri approach integrates 3 different ways in order to assess these troubles. So first of all, we perform a measurement on the field using sensors. We can use our Y4Agri sensor, but of course we can also integrate third-party sensors. Then we have a software running with artificial intelligence technique. So we are able to perform a kind of estimation of the soil humidity. And then we can use these two methods together. So we are able to also to perform a prediction using models and weather forecast together. So we also can integrate satellite data about weather forecast. So basically we are able to provide a farmer to answer to this main question. Can I enter a field with my tractor without performing damage on the soil compaction, about the soil compaction? It's possible to perform tillage. When we work with tillage, we mainly focusing on plowing, so the plowing action. Is it possible to plow my field now, today? And then is the correct moment in order to perform a treatment on my crop? These are the main question that we are able to solve with wireframe solution. Basically, our solution is a combination of different models, of different mathematical models. So the main model is a soil water balance models, which is able to perform a water balance every day. So this model is able to perform a simulation of all the water which is entering the field. You can see these pictures on the right, and all the water which is leaving your fields every day. Then with mathematical approach, we are able to transform this water balance model in a volumetric water content, which is basically a number, a percentage, and is the same value that you can measure with sensor. Then, based on starting from this data, our artificial intelligence is able to assess the trafficability and the workability in each field, and another artificial intelligence DSS, so software, is able to assess if there is the correct moment today or now in order to perform spraying and fertilization. Basically, the artificial intelligence technique is able to set up every day a different limit, and we have to identify for each field, for each day, two main limit: a wet limit, you can see this picture on the left side, and the dry limit, you can see on the right. This because when you perform plowing, the optimum window, so the optimum characteristic of the weather and of the soil are in the middle of a between a wet limit and the dry limit. So basically, from the graphical user interface, so for the final user, we deliver a ready and really easy to read index. One index about trafficability. It's simply it's a simple traffic light index, so you can see a very good situation, an intermediate situation, and a bad situation. There is an index about trafficability, an index about workability, and the other index for treatments and for fertilization. The benefit for final user, you can reduce time and fuel, of course. You can minimize the soil compaction, and you can also avoid the evaporation of soil structure. You can increase the lifetime of your machinery, and you can also reduce the maintenance cost of the machinery. And using our time window, you can also improve the efficiency of your treatments about pesticide and also about fertilization. I wanted to show you in the last minutes some results of our pilot fields. So this is wine pilot fields in Italy. It's a very famous production fields about wine. We are in the DOC Prosecco area. Is a production field whose wine is going to be sold all over the world. And here you can see the output of our DSS model. So basically, with the blue line, you can see the water content of the soil, which was assessed by our DSS with artificial intelligence. And with these three lines, you can basically see the threshold. So you can see the optimum condition with the red line, and then the upper limit and the lower limit. This means that if we look in 1 year, you have a lot of days where the workability is not recommended. You have some days where the workability is possible, but you are not in the best situation. And the software is able to identify exactly the 20 days, in this case, where the conditions are perfect in order to perform workability. Then we have the same idea we can apply to trafficability. Trafficability basically is the possibility to enter a field without to stock with your machine on the field, or without perform any bad action on your soil. And this is the future step, because at the moment we realized that the DSS way for agri model is reliable for approximately 80% of the tests that we have done in the field, but we are aware that there are some future steps that we can perform. For example, these models need to be calibrated field by field, and this need time. And another step that we are working on is that at the moment, our model cannot take into account the type of the tractor and the size of the tires. And so we are trying to include also these parameters in our DSS in order to be more precise and more accurate. I ask you sorry in advance because I have to run in the fields with the customer, and so I cannot stay with you for a question and answer, but I leave here our website and our email so that you can write us for any further information. Thank you very much for your attention.
Thank you, Federico. Great presentation. Just one question before you do have to run off to the field.
Sure.
DSS, this is decision support system, right? Just for the non-technical people like myself,
Yes.
It's a decision support system for farmers. Okay, it looks like an excellent product. Thanks very much for the presentation. Thank you.
Thank you very much, and sorry for my leaving now.
No problem. Okay, next we're going to have a video presentation from Thomas. So Thomas from SenseEdge, who will talk about their product Soily, which provides and integrates easy-to-use soil moisture sensors to improve workability of soil and reduce irrigation costs. So just bear with me for 1 second, and I am hoping this share works correctly.
Hello and welcome. My name is Tomasz Szukle. I'm CEO of SenseEdge. Our company was among 10 top companies winning this competition within the Open Call #1 on the topic of soil workability. Our project was called Soily, and our aim today is to present our results, and especially important, how did we continue the collaboration with our partners. So our company, SenseEdge, is focused on standardized IoT sensors. We also offer customization of our sensors for larger deployments. We focus on harsh environments with the use of sustainable material and supporting LPWAN technologies like LoRaWAN and NB-IoT. We also have a sensor maintenance platform that we call Sensimo. We have several partnerships laid out in Europe as well as in Australia. So we have been recognized as top 10 not only here in this Open Call, but also with other competitions in startup area and also LoRaWAN. So let's jump to the project itself. So Soily is all about implementing our existing pilot technology into real life and to show its value to farmers. And we have a vision that IoT can actually help farmers to be more sustainable. So they can better monitor and predict the soil workability, they can help to reduce the environmental impact, they can better exploit their existing machinery, and they can save money and reduce the cost. So let's have a look, how did we do it? So we deployed our sensors in 3 locations altogether. So the first location, and all 3 of course as well, are in Slovenia. That is also the case because during the Corona time, we partnered with a local Demeter partner, it's ITC cluster, and we worked together really nicely. They really help us to introduce local pilots that we were able then to upgrade with our sensors as well. So one location was with, all locations were in the northeast of Slovenia, so Vanečas, Ivanovci, and also the vineyard in Pince. So there were 2 orchards and 1 vineyard. And for one location, we also deployed a bit more sensors. It was not just like a POC, but we also extended the pilot, as we will show in the coming slides. So it's also important to integrate with the Demeter platform. We used our own Sensimo dashboard. It's a middleware platform that also has visualizations. And actually we received really nice feedback from the users themselves that they find these visualization really useful and straightforward. So we gave them direct access also to our platform, and they are still using it today. And that is also due to the fact that we enlarged the deployment of our sensors in one of the locations, so that second location. So we revisited them, we deployed more sensors there, and we also proposed a new project together. It is also important that now we work with ITC cluster to even greater extent, and now we are deploying sensors on 8 farms around Slovenia with a focus on further help farmers. So the important aspect, as we are doing now, is that we see that due to the higher prices of fertilizers and pesticides, IoT makes even more sense. So now we are helping to reduce fertilizers and pesticides by measuring microclimate in different locations on farms. We also help to monitor soil moisture to reduce the cost of the irrigation. We also supported temperature monitoring in compost and mulch piles, as you can see on the left-hand side with a new project, where the temperature has to be kept at around 75 degrees, not to exceed that, otherwise the quality of the compost really drops down, and that impacts the yield and of course earnings of the farmers themselves. We also support the level meters for smart city applications, agri applications, and also now entering into the space of smart buildings with indoor air quality monitoring. So that would be briefly about us, about the project, about what we do. So I'd like to thank you, and also like to invite you, let's build use cases together. Thank you again. My name is Tomasz. Here is my contact, so just reach out if you need any more information, and yeah, see you. Thank you. Hello and welcome. My name is Tomasz Szukle.
Oops, that started again, sorry. Okay, and thanks to Tomasz for that. That was an excellent presentation. And we are going to move on to our next winner, which was Deep Planet. So the next speaker is Natalia from Deep Planet. Natalia will present Soil Signal, an innovative decision management tool using Earth observation satellite data, IoT sensors, and machine learning AI to detect and predict soil moisture and provide recommendations to farmers ahead of time. So Natalia, if you're there, could you share your screen, please?
Yes, I'm sharing. Can you see my screen?
Yes, perfect. Thank you.
Okay, awesome. Thank you very much for the kind introduction. Hi, everyone. My name is Natalia. I'm a CTO of Deep Planet, and we provide AI solutions and satellite imagery support for the farmers across the globe. So the problem that we're addressing is the soil moisture on farms, both equipped with soil moisture sensors and those without soil moisture sensors. So wrong understanding of soil moisture limits soil readiness, soil health, and prevents correct irrigation and fertilizer usage. So there are a lot of costs for ongoing monitoring of soil moisture conditions, and a lot of spends on tractor runs per year, and also high costs on sensors which are not covering fields efficiently. And incorrect soil moisture readings causes environmental degradation and high inputs, including scarce resources such as fresh water, fertilizer, and others. The solution which we propose is software as a service platform, which enables farmers to access satellite data and offers also AI support for the farmers, which interprets this data, which is not very easy to read, and to integrate with soil moisture readings. So we suggest two solutions. First, for the usage with ground sensors, soil moisture sensors, and second, without soil moisture sensors. So both solutions provide current soil moisture prediction for each point in the field, not only at the places where soil moisture sensors are actually installed, and also provide predictions for up to 2 weeks, which is possible to combine with dynamic irrigation systems. And it can be served as an input to dynamic irrigation system. So the ground sensor solution provides subterranean modeling for up to 1.5 meters underground and 92% accuracy. The solution without ground sensors obviously provide only coverage for the top layer of the soils and about 80% of accuracy, but it can be used in any field without installation of additional equipment. So just to sum up, we propose adaptable solution that integrates with IoT and third-party platforms. We're using industry standard outputs, which is easy to combine with any sorts of inputs for any sensors that are installed in the field. Customizable to any crops. We're currently using it mostly with vineyards, which are known to be very, very sensitive for soil moisture. This is our most common users. So we work with the farmers across the globe, including Australia, our main client, New Zealand, South Africa, Spain, France, Armenia, and UK. And we are expanding very quickly. We are able to integrate with existing soil moisture platforms and agri-services, and we adapt to business objectives. We add value to the data generated by the farmers and allow them to use their suggested inputs and outputs, and we're GDPR compliant. So the only fine-tuning that is required for our solution is adapting to geography and weather, which requires taking local inputs such as weather station inputs, or, for example, readings from local weather provider, and availability of satellite data, which is 96% coverage across the globe. So it's pretty easy. And we offer soil moisture models, and it's 100% interoperable with Demeter system. So just to sum up the benefits of our solution, we lower tractor use costs and reduce soil compactions, we minimize interoperability issues and reduce environmental impact. It's accessible to farmers without soil sensors, and it lowers irrigation and nutrient costs. So these are some technical details for the both solution. If you have any questions about this, I am happy to go through it in Q&A session. So soil moisture with sensor solution produces outputs as videos. So you will have a 3D map of the soil moisture in the vineyards, which is produced weekly, and it allows 2 weeks future predictions. And soil moisture output without sensors produces an image as a heat map of soil moisture or a graph. I will show exact output below, how it can be read. So as mentioned above, we input satellite, optical and radar data, and some crop agronomy data, some soil moisture sensors data or historical data when needed, and we use it together with satellite imagery and combine it with our machine learning solutions and offer easily interpretable solution on the platform. So here you can see the types of outputs that we produce for both solutions. So on the left, you can see in-depth map for a vineyard, which provides a heat map of soil moisture at each point of the field. And it is a video, so it can be assessed from various viewpoints, and it's like presented in rotation. And on the right is soil moisture prediction without sensor, which is displayed as a graph. So you can access your soil moisture readings for current moment and for 2 weeks in advance. Yeah, thank you very much for your attention. Looking forward to your questions.
Perfect. Thank you, Natalia. And if there are any questions, please add them to the Q&A box below. So our next speaker is, one second. Our next speaker addressing topic 1 is Eduardo from Metrica 6. Eduardo has prepared a video presentation outlining their solution WaveSense Fields, which is a cyber-physical solution for water efficiency in green spaces applied to the smart city and smart agro environments. So I am going to share that video right now.
Good morning, everyone. I'm Eduardo Dueñas, creator and team leader in WaveSense Fields, and this is our story. So I'm gonna share my screen with you. I guess you can see it now. So here it is. Well, you know, the United Nations stated that 30 years from now, we will have water only for 60% of our necessities. Each of us consume around 120 liters of water daily, but did you know that around 35 liters are completely wasted every single day? And there is so much we can do about it that we couldn't just simply stay quiet. That is why I created WaveSense, saving over 35 million liters of water already, fighting against hydric poverty. In this journey, I discovered many people that felt the same way too. They are now the captains of a committed team, an experienced team of 12 people. And this league is continuing to grow with new partners and new allies, our investors. Together, we have surpassed many milestones. Over 2 million euros in accumulated incomes, many national and international awards and recognitions from entities like the United Nations, 17 international patents, and the story goes on. WaveSense is a technology formed by a platform for managers, a mobile app for users, and a set of devices to perform our magic. WaveSense creates a digital twin of the installation with thousands of hardware and software combinations to customize the solution to your needs. It can also be integrated with other technologies for an extended impact. We started selling our first WaveSense solution in Spain before the pandemic, a solution that avoids the wastage of cold water that we normally dispose every time we want to use hot water, but have to wait for it with the tap turned on. During this semester, we will be finishing our digital tools, the platform and the app, that will become the engine for the international scalability of WaveSense. Next in line, there are several European projects to develop new functionalities for leak monitoring and control and for smart irrigation. Consequently, you can say that there is a WaveSense solution for everyone, from families to businesses, real estate developers or public administrations, among others. And more importantly, WaveSense is not just a tech solution, but a solution for the mind, a tool to raise awareness for a better use of resources, a tool we all can benefit from. And this is when we started our participation in the DEMETER program, to further develop our WaveSense technology applied to smart irrigation in agriculture and in other urban green areas. Here you can see some of the aspects related to the customer's profile, the market, or the environmental impact. Our business model is a combination of traditional marketing and product as a service. Both are needed and adapted to clients. Product as a service has higher scalability, but the sectors we play in are mainly traditional. This can also be seen in our go-to-market approach, where we count on traditional figures like licenses, distributors, or prescribers, but also with digital allies to exploit this market niche, as in marketplaces, professional networks, or sectorial databases. WaveSense fields can be applied to many aspects of the irrigation processes. And there is still a lot we can accomplish, like the AI and big data to optimize the irrigation tasks, the detection, warning, and cut of water leaks, as I have just mentioned, and the risk, and also the prevention or the risk of preventing the pipes from bursting when there is a frost. So all those things can be yet to be developed. After the Demeter final stage, we continued developing the system. These are the latest milestones that we achieved. All the devices are working properly. These devices are a water pump, a motorized valve, a soil sensor device with humidity and temperature sensors, an ambient sensor with temperature and relative humidity sensors for the ambient, and also with integrating air quality monitoring systems, and also the gateway for the communications. We are working also in several real pilots to gather more data in order to calibrate some of these sensors. Simultaneously, we have started to develop the algorithm for the automatic smart irrigation cycles. We have also integrated Wisens fields into a collaborative smart city platform called iMind. These devices are already sending information into our database, which is being represented into the platform. Next steps in this area are to optimize the user experience and user interface for a pre-commercial launch of Wisens fields at the end of this year. For more information about the integration with Demeter, its benefits and potential partnerships, please check our websites and the social media. And that's all from my side. Thank you very much. Good morning.
Excellent. Okay. So that is topic 1 complete. So now we're going to move on to topic 2. So we had one winner within topic 2, and that is Gunter from Terranea, who will introduce their solution CAP-P, which supports the needs of the Common Agricultural Policy through a geotag photo app. So I will stop sharing, and Gunter, I will allow you to share.
Thank you, Dave.
Take it away.
So screen sharing works, right? All right. Hello, I am Gunther from Terranea. We are a German consultancy and location-based services provider. We have a strong history and focus on geospatial services, satellite data analysis, GIS analysis, mapping, and so on. And we also do lots of integration of geo-information with other software tools, spatial integration of spatial and non-spatial data. Yeah, so in agriculture, we have an increasing demand for transparency. Some of you have probably heard the term from farm to fork, which is requiring a fully transparent production chain from the farm to the consumer. But it's not only the consumer that demands transparency, it's also food traders, food producers, and especially the government. And with this CAP app that we developed here in Demeter, we wanted to address specifically the government requirement. And Dave already gave a nice overview and introduction about the background and the CAP activities. So CAP stands for Common Agricultural Policy. In Europe, it's this big framework about subsidy payments. And within the CAP, there is a component that is called the Integrated Administration and Control System, the IX. And within this IX system, the farmer applies for subsidies, and then there are checks if everything is correct that is happening on the field. And then there is a payout at the end of the control process. And as Dave has mentioned, this whole control approach changed now through a reform that integrates now a continuous satellite monitoring of the parcels of each farmer. And with a satellite image, you can go down to a certain scale on the field to identify something. But when we talk about smaller parcels, then there is a limit of simple visibility, and therefore the idea of a photo app was introduced. And so our objective was to develop such a mobile app that allows the farmer to collect information from his fields just for documentation and also to prove some farming practice. And this is not only, of course, not only for the administration, but imagine a farmer huge farms are usually involving also subcontractors who are doing a lot of field work, be it plowing, be it harvesting, and so on. So sharing information, documenting activities on the field is also a task for other stakeholders in the whole farming process. A very general demand is, hey, everybody has a smartphone. We have all kinds of different operating systems, versions of operating systems. So, hey, yeah, the app should run on a standard smartphone, and we should have the possibility to exchange information and data with the paying agency. Developing apps can be tricky, but well, there are plenty of apps available. You find plenty of apps in the app stores. We have some specific issues here because, yeah, as I've mentioned, this IX system, that's a whole ecosystem of data and software tools available. So the farmer can apply for subsidies. So the farm is somewhere stored in a central database. Then geographic information about all the parcels that are applied are stored in a database. And now we have the requirement that the paying agency needs to be able to send a pull request from the farmer. They need to send a message to the farmer saying, hey, we need now a photograph from a certain parcel of your farm. Then, of course, we must make sure that farmer A gets only information from farm A, parcels from farm A, and not from farm B. And so that we need a seamless integration with this IX system or the IX environment, and what makes the thing unfortunately even more tricky is that each paying agency runs its own system, more or less. In Germany, we have 16 federal states, and you can imagine we have 16 different solutions. And when we go to other European countries, we might have a similar situation. So that is a bit a tricky part when it comes to the implementation with the paying agency. Besides this big IX environment, the IX challenge, of course, we have also technical challenges in the smartphone. We need to integrate sensor data from the smartphone, a GPS unit, and then we need an API because we want to share the photographs with stakeholders as well. That's the overall idea. So to simplify the workflow, we have an app, and the app receives some information from the IX, be it subsidy declarations, be it geographic data. Then we need this clarification request. We need an API to this IX system. Then the farmer is using our CAP app, taking photographs in the field and returning the photographs together with attributes and metadata. So how did we solve that? Well, a critical thing in app development is the different operating systems. And when we talk about operating systems, the different versions, and that was too complicated now to offer an app for Android and iOS at the same time, and also then considering the different versions. So we decided to go for a progressive web app, which makes the whole thing insofar easier that it's a browser-based application that can run on every operating system and also on a laptop or a normal computer. Since we did not have a real integration with an IX system, unfortunately, that was actually our hope, to have a user in Demeter where we could get, or where we could test such an integration. That was not possible, so we built a kind of dummy authentication authorization system, which is designed in such way that it can be quickly and rather easily adopted to a real system. Then we integrated background information. Our app is map-based, so we had to integrate some base layer, some static base layer, satellite and maps data, and on top of that, geographic data that is, or should in reality be, the data from the land parcel information system that is available in each member state. And then we built such a request function so that we could receive a request on our mobile phone, and that request includes information. Please take a photograph on the southwestern corner of parcel A to document, I don't know, some environmental measures that you apply on a parcel. And then the farmer can respond to that request and fulfill the request and return the corresponding information. Sharing data is nothing new in times of cloud environments. However, yeah, since this whole IX system is so organized and structured, we need yeah, a data model, and there for data sharing, and for the photo sharing there is no data model. So together with our coaches, yeah, we discussed that we should put a focus on the design of this API to share the photographs and to design the data model. And that is yeah.
Sorry, Gunter, to interrupt.
Yeah.
We're hitting just over the 5 minutes there, so if we can wrap it up in the next 30 to 45 seconds. Sorry.
No problem. No problem.
Thank you.
So yeah, we designed the data model, which includes user information, farm information, parcel information, and then that links that to the photographs. Of course, we integrated also Demeter services. That is not a must-have, because yeah, we are more focusing on the IX environment. Nevertheless, of course, we used BSE to register the endpoints of our photo API, and the ACS manages this access to it, and the enabler hub we integrated yeah, as a kind of warehouse to present our app. All is transparent and public, so you can test the front end using the first URL. The source code is available on GitHub, and also the photo API endpoint is documented. And so what's the way forward for us? We have identified the initial public tenders from paying agencies for such a photo app, such a CAP-like app. The first call that we identified, we could not address yet because there were some, well, IT security demands included that we could not fulfill at that point. We have to keep in mind, we talk about government users, everything must be very secure. And another important point is that when you imagine how many farmers we have in Europe, and a paying agency requests hundreds or thousands of photographs from farmers, it's very, very time consuming to interpret each photograph, yeah, visually by hand. So we actually plan to look into a further component, which is an AI-based photo interpretation, so that we could make a kind of pre-selection and sorting of images that the AI supports then the person in the administration with yeah, interpreting if a photograph is documenting the farm practice correctly or not. That's a summary of the CAP app. Thanks very much.
Perfect. Thank you, Gunter. I know there's loads to cover there, and apologies for cutting you short, but I actually have a lot of questions for you as well around geotag apps. There is one there at the moment. Miko has asked a question, but Miko, if you could put that in the Q&A, or somebody may copy it over to the Q&A panel, we can answer it later. So next we're going to move on to topic 3. Thanks again, Gunter. And I am going to share my screen for a video again. So we had one winner addressing topic 3, and we have Alex Inza of Elliott Cloud, who will present a video recording outlining Elliott Isobus, a gateway software component to improve and increase the interoperability between heterogeneous hardware and software systems used in the agri-food domain.
Hello, I'm Alex from Elliott Cloud, and today I'm going to talk with you about our Isobus enabler. First, I'm going to give you a brief introduction, followed by the explanation about our solution. Then we are going to talk about how our solution is integrated into the Demeter platform and the benefits that this brings us. And finally, we will end the presentation talking about the next steps that we could follow. As Elliott Cloud tries to improve the actual technology and the impact it has on society, we think that this project has been a great opportunity for us for achieving this, allowing the farmers to gain greater control over their tools and the related processes. Our solution is an application that allows the user to control the tractor implements such as mowers, trillers, and watering systems, and also retrieve the information these implements provides. For this purpose, the enabler can listen to incoming packages from both edges, isobus over CAN and request over HTTP. The Exposit API allows the user to interact with the configuration of the application, managing the opening and closing of the communication, allowing the use of up to 7 Canvas devices simultaneously with the loss of information. Some of the capabilities are connecting the multiple canvases simultaneously with an identifier for each one, the possibility to include a virtual CAN device to test the different components, the registration of all the frames present in the canvas, the possibility to decode the frames received, a data model which is compliant to AIM format and standard into the agricultural IoT world, a fully functional REST API to interact with the application, retrieve messages, passes, and change configuration. The integration into firmware with Orion Context Broker. The easiness to include a persister component to register all the data into a database for historical records, such as Duraco. And finally, the isolated application using Docker containers. The integration with Demeter uses the following components. Endpoints are listed in the brokerage service environment. The application is listed in the Demeter Enabler Hub, where the users can access to documentation and the software components. And the data format that we use is AIM compliant, a format utilized by Demeter. Some of the benefits that we have encountered regarding the integration with the Demeter platforms includes the possibility to have more users, which could lead into the use of anonymous data to improve and optimize the processes such as irrigation or the fuel consumption of the truck. With the BCE, we gain interoperability that allows the user to develop their software based on the endpoints we offer. The AIM format is a standard in the agricultural world, which could lead to the possibility of integrate our application data into another product. Finally, some of the next steps to take are to continue improving the application and take advantage of the new lines of business that are opening thanks to the work with Demeter. These are, for example, in the first case, improving the communication used in the application. In this case, we are only using GSM modules. So we could try to change them from a different narrowband protocols such as LoRa or Sigfox or Zigbee. And related to the new lines of business, we might want to explore, for example, trying to sell the product for a contractor that uses a leasing system for industrial vehicles, for example, in this case, trying to improve the fuel consumption or how the user is managing the vehicle. And this is the end of the presentation, and thank you all for being here, and hope you do well. Bye.
Excellent. Okay, so we are going to move on swiftly because I know we're running a little bit behind time. So we are moving on to topic 4, and this is blockchain-based solutions for agricultural applications. So we have Pierluigi, who is from Seedsbit, who will introduce Persephone. I'm hoping I pronounced that correctly. A system that guarantees the quality and validity of data, providing a clear track of events together with the reason why they occurred. It includes tracking and tracing abilities for products and transformation processes. So over to you, Pierluigi.
Thank you, Dave, for your presentation. I'm going to present our project, which is named Persephone, which is Demeter's daughter in the mythology, but also in this case, because we propose this blockchain solution for agricultural application in top 4. And in particular, we are going to present how blockchain provides some support, some services to Demeter. We added two services: traceability for, as you said, for products, and also production processes, which is something completely different, because in some cases you can track and trace the product, but you don't know exactly how the production process was, if it was also friendly for the environment, and so on. And the other aspect is document, because the tracking documents means also tracing information. And so our motto is inside our platform, the name of the company is SEEDS, the name of the platform is SEEDSbit, and in BIT we just BIT, we have blockchain for information traceability. So tracing documents is also a part of our goal. In Persephone, we integrated these two services, so document and traceability. And as for traceability, we focused on a specific product, the olive oil. Why we focus on that product? Because we don't only consider just the capability for a generic production, but we also included smart contracts, which are completely nested, and since they are logic and they validate data, these smart contracts are nested within the field and the specific product that you are going to trace. As you can see here in this slide, we have the traceability among production till the distribution till the restaurant. So we go to Horeca, hotellerie, restaurant, cafe. So far beyond what usually is said to be farm to fork, because the fork is usually fork when you eat at home, but not the fork when you eat outside for extra domestic consumption. And all these steps are very useful because, as also Kevin mentioned at the early beginning when he presented the whole project, the approach of this project, of the Demeter project, is a multi-actor approach. And with the blockchain, we just link together all these multi-actor approach, transformation, conservation, and so on. And so all these actors provide data, and all these actors provide data in a trusted, in a trustful, and in a linked way, because we can provide data trusted within the single entity, but to make this useful and across more entities, we need the blockchain and our contribution. And we can see how the blockchain provides this trust and truth. Trust because we go in, even in an untrusted environment, so we think, sorry for this, but that any other provider is untrusted and is as its own, let's say, detailed interest for that can be also competing with the other interests. And the truth, because we make a preliminary validation of data that are written before being written on the blockchain. During the 3 sprints, we went through our goals so we analyzed and then developed and mapping our solution within Demeter. And we also linked to the ontologies that were provided by Demeters. So thank you for this, because this enriched also our product and our services. And in the sprint 3, we provided the blockchain nodes to the Demeter, and also smart filters for make this validation, the web mobile application for this. This is a screen of the web application. You see that is SEEDSbit completely also customized for Demeter. And this is how we track and trace both geographically, logically, with a diagram that is dynamically rendered from the blockchain, coming from the information that we exchanged with you, defining how we had to define our ontology. So we integrated with this. And also on the right, the informative plane, where we have information that are trusted and validated. So this is the page of the product. So you have the digital twin between the product and the digital twin of this product through the QR code that is also applied on the specific selling unit. And here we have the platform that is always for Demeter for tracking and tracing documents. The main contribution here is an ontology model for blockchain technology. So your ontology model has been into this project linked, nested within our blockchain-based platform. And so you can take the benefits of this introduction, and everyone, of course, everyone in the Demeter project. Of course, we provide this with the open API as you asked, and you can integrate. So as a future work, it would be nice to have an integration of not only other Demeter participants, but also, for example, other open call participants towards this application. This is in fact the possibility to create tokens and to integrate and to cooperate your own platform with our own. And this is just the team that contributed for this project. This is a part of the SIGMIT team. So thank you for this opportunity, and we are glad to cooperate further depending on your needs. Thank you.
Thank you very much, Pierluigi. Very, very interesting project and topic to be covered. I'm going to move on swiftly, and now we're moving on to topic 5, the business process integration, or BPM. And our first speaker is Mitch Hancock of I4FS, who will present Debbie. And Debbie integrates a business process management tool with a visual analytics component into farm management activities. So over to you, Mitch.
Hello. I'll share my screen now.
Thank you.
Does that look okay to you?
Perfect. Take it away. And if we can try and keep to 5 minutes, please, Mitch, we're starting to run low on time. It's my fault. I'm sorry.
Yeah, no problem.
Thank you.
So the first thing we did was we have a BPMN tool. So we tried to find where we could put this into Demeter. The one we found was 5.4, the transparent supply chain in the poultry industry. The main focus of this topic so far was the well-being and health of the poultry. So we decided to focus on the business side of that, with the HR, the sales, the orders, that sort of side on it, the transport of the orders. So what we did was we made an order processing BPMN process. We also made one for the whole like slaughtering of the poultry. We made one which included the workers. The workers had hours which they worked. We made a tool to schedule the orders within their times, and we also accounted for any if an employee was sick or if an employee was on holiday. You could reschedule all of the orders within that scenario. The one unfortunate thing we did have is we couldn't find any partners which wanted to get involved with us. So we did have to simulate the workers and the data ourselves. So we had to do a lot of research into the poultry on our own without any help from any of the partners. So it is all just dummy data or simulated data which we used. So this is one of the processes. This is the one of the slaughtering of the poultry. So we had inputs such as the amount of stock, the orders, and the HR, as I mentioned. And we had some constraints, which is the delivery times of the orders, the stock of the chickens, and also the task force. And we made it possible to reassign based on any unavailability of the workers and such. So for our development, one of the main things was setting up the databases to track all this. So we need a database for the workers, we need a database for the chickens and their age and such. And we had to simulate the chickens growing and their weight and things such as that. We also had different types of orders which you can make, such as the type of chicken you wanted. Same with the workers. So one of the main developments was the scheduler. So we could schedule based off of the orders, the size of the order and the type of order, how long it should take based off of the staff which we had available. So that was one of the main things. And we also created an analytics dashboard to track all of the orders, to track their status and to track the workers. So this is another picture of what one of the BPMNs looks like. This is the slaughtering one. No, the ordering, sorry. This is an example of what the database looked like. So we had a database of the resources, customers, orders, workers. It was just all done in MySQL. So this is the schedule with the analytics in the background. So we had a start and end time for each order. We had the amount of orders, we had order IDs, and we had a status of each of those orders. This is some more of the analytics. So as you can see, the processes are split up into different tasks. They're assigned to an employee with a start and an end date, and when they should be completed by, and how long it did take them to complete it, compared to how long we estimated it would take. Same with the workers, you can see their status, the skills which they have, and the skills relate to the different tasks within the process. So for the integration, the main integration was with the DEH, just for allowing navigation from the DEH to our tool. Hopefully it'll gain some traction on there. We did look at the other forms, but we couldn't find anything useful in the aim and such that could help our use case. The main benefits of integrating would be new industry. We've never looked at this sector before with our tool. Hopefully we'll gain some visibility to the partners in this project, be able to collaborate and have new opportunities going forwards. So the next steps is just to keep the tool available, hopefully find some new collaborations. And that is everything. Thank you very much.
Perfect. Thank you, Mitch, and thank you for staying on time as well.
No problem.
Okay, our final, I should say last but not least, speaker is Cohen from Hyler, who will introduce OptiFlaxit. And OptiFlaxit is a solution to future-proof data exchange during flax harvesting towards industry.
Yes, hello, good afternoon. You see my, or good noon, I would say. You see my slides?
Perfect.
Okay, so a couple of minutes update on OptiFlaxit from the company, project done by company Hyler. Very short about Hyler. Hyler is a scale-up in Belgium, focusing on innovative agriculture machinery for niche crops, I would say, or fiber crops. So we are not playing in the field of big machines or big hectares. So working on, in this case, on flax, for example, in Europe. So, and growing very fast. So because we see a use of flax going up more and more, so these kind of, I would say, alternative agricultural sectors are gaining importance due to, in our opinion, the Green Deal. Here we are all have seen the results of the Green Deal, so we need to reduce pesticides, fertilization, and so on. But you also have climate change and things about sustainability and circular economy. So we think that the use of, in this case, flax, but also other crops like hemp can be very useful to help in achieving those goals. I will not elaborate, but this is the reason why we see growth of importance in these kinds of domains, and therefore we also need machines to do this. So this is a typical flow of a flax harvest process where a customer can get the machines at Hyler. And in the project with the Demeter, we wanted to add, I would say, a data layer on top of it. Even in these niche markets or smaller markets, I would say, a data layer is wanted to improve the processes of all the stakeholders in this sector. And that's what we wanted to focus on, to start immediately with a good solution, being able to deliver data towards other stakeholders. So we did this by using telematics devices, of course, in this case Bosch, where we then built upon an API following the Demeter principles, because we wanted to have, I would say, a very good start, and also think about standardization of data exchange to be able to use and reuse the developments, and also then make this data available for the industry to improve their processes. In this case, we did an example with Libico, which is a Belgian industry player, which wanted to have a view on the amount of yield of flax, so to optimize his machines and his setup. These are examples of the tests we have done in the summer last year, sharing of the data of these kinds of machines. So a lot of interest was in this machine with data, and this is some screenshots of the application which we shared with the industry, showing where the machine was, also engine parameters, and in this case the plant length, because it's very important to know the length of the harvested flax in this case, to optimize the machine settings of the industry partner. And more detail, also a detailed map of the field and so on. So this was for a lot of these players in this niche sector an eye-opener, the data flow around these machines. So, and it really gave them the possibility to proactively improve their processes. That's a very important takeaway I want to give here. Of course, we integrated, like the previous speaker said, with the different Demeter components, like the Demeter Enabler Hub, of course, so that our service is now discoverable in the API, and also the AIM model, which helps us in, I would say, delivering a standardized data way, so that everybody else can understand what we are sharing with them. And this is the base for future developments. So as a summary and takeaway, I want to share with the public, because that's, I think, most important. It's really important that we have this data layer even in niche sectors. I think that's an important takeaway. Certainly for a scale-up, it's very important to have the standardized setup. So by participating in the Demeter project, we are able of getting access to information to give our API standardized way, and also giving farmers much more data to work with. But not only farmers, and certainly in this business process optimization project, we also certainly wanted to focus on the ecosystem with the industry. So the data sharing with industry, if allowed by the farmer, of course, helps them in optimizing their processes. And of course, we are already busy with next steps, thanks to this first project, to work further on this data layer. And as a last topic, which I think is very important, besides having the development and the information, being part of a project, European project, gives you the possibility to network, to get to know new people, new companies, to maybe develop new feature services in the future. And that's also one of the reasons why we wanted to participate in the Demeter project at the end. So I think that's very fast, Dave. The project of OptiFlaxit from Heiler. Yeah.
Perfect. Thank you, Koen, and thank you, everyone. I think we could probably have a 3-day conference on the amount of information that's been covered in the last hour. So thanks very much. We are moving on to questions and answers. So I guess I have one question to everybody, and seeing as you're up first, Koen, I might ask you first. So describe in one sentence to describe the major benefit of working with Demeter. What was the major benefit to you?
The major benefit is to have access to the standardized, to how we should share data, the standardized API, and I would say you are put in a framework to follow this really. That's the main reason. And of course, due to COVID, we did not have a face-to-face meeting, but the networking is for me the second part.
Perfect, thank you. And same question for Natalia.
Yes, I guess we have exactly the same experience. It was the first time we had to interact with a standardized API and to integrate our platform into something else. And it was a good experience because we're gonna know how to do that, and we really appreciate help of the Demeter team. Yeah, thank you for that.
Thank you, Natalia. And Gunther,
Yeah, same here for us. Being simply integrated in a large community of application developers from the agricultural domain, exchanging with them regularly helped a lot, and then also getting an understanding how API development, standardization could work, and so on. That was definitely a big help.
Excellent. Pierluigi?
Yeah, from my point of view, one of the best opportunity given by Demeter is the possibility to provide this multi-actor approach, because this is something that is particularly true in the case of the blockchain, wherever different also interests come, one fighting against the other, and so this heterogeneous scenarios provided by Demeter is very important to validate what we are doing, and we can provide also a good opportunity for the Demeter consortium to test and to try in let's say not untrusted environment, but with trusted technologies. That is the main goal, I think, that and the main benefit of integrating SysBit within Demeter.
Perfect. I think I would answer multi-actor approach as well, which might be a bit obvious, but we do have a report coming out very soon called The Farmer's Voice, where we sent a survey to farmers across Europe and the world, where trust came up as a huge barrier when it comes to adopting these digital technologies. But again, we can speak about that in another webinar. I don't want to hold up too much more time. Finally, Mitch, same question to you, please.
I would say experiencing a different sector we've not worked in before and gaining the knowledge that brings.
Excellent. Thank you, Mitch. We have one technical question here from Miko, and this is for Terrania. So how do you detect fraud and cheating of pseudo GPS? Bit of a technical question, but if we could answer that in 30 seconds or so.
Thanks, Miko. That's a critical point. And I'm not sure if I can really answer that from a technical perspective. Positioning or spoofing of location data, that's a big issue. And without being a Galileo expert, I know there is on the one hand some encrypted message authentication protocol, but I don't know how easy it is to implement that then in a mobile phone app. Then when we also talk about Galileo, there would also be the option that you have some public regulated services which are dedicated only to government use, critical infrastructure, police, emergency services, and so on. The question is, could agriculture be such a use case too? Probably not. And a completely different topic, what we once tried in another project was where we had a similar question. Can we take field photographs, transfer it somehow in the cloud and make sure that the location of the photograph is really the right location? And that is where we applied blockchain, which might again be a big overhead over such an application. But I guess that could also be one solution to be discussed. But yeah, I'm not the technical expert here, so some suggestions would be would be appreciated.
Yeah, I guess the Galileo service that I think that's in beta at the moment, so that will be released pretty soon. And on phones, they actually have built-in fraud detection with the APIs that they use, the geolocation APIs. So this for Miko specifically, but they use assisted GPS, which allows you to get your GPS from whatever Wi-Fi tower you're connected to, your cell tower, your phone's position, the GPS chip that's within it. And those APIs will check for spoofing as well. They're not 100%. I don't think anything will be, but you know, somebody is always going to spoof something or find a new way. But yeah, there's plenty that we can speak on again at a later date. If anyone does have any more questions for anyone here or any of the speakers, please feel free to email us. The email address will be shared at the end again.
Dave,
but for yes,
Dave, I have actually a question. If I can take a minute, advancing a little bit my presentation now. we plan to launch an application for co-creation, connecting farmers, developers, advisors. My question is for the open call winners, do you think that the current market is efficient solving the problems of farmers? So can the farmers find the solutions they need without much trouble? Or instead there is some gap there that we can, some opportunity that we can, hopefully Demeter can cover, or maybe somebody can cover that gap, facilitating the connection between farmers and solution developers. What is your general thought? Do you see an opportunity, or is the market efficient enough in that regard?
Yeah, go ahead, Gunter.
Yeah, Jorge, I have this satellite remote sensing background, and there are plenty of applications now, or software providers, data providers for farmers, especially for to support precision farming. And I realize myself, there are so many established companies, startups, then established companies having more this farm consultancy background and not an IT. They are not an IT company. So for me, it's really too much to really to keep an overview. And I think a farmer's job is to farm, to cultivate the fields. Then there is a lot of documentation efforts. So then to look into all kinds of offers that are on the market is really on top of that. And a lot of work. And just a week ago, a friend of mine shared a link with me. There is a startup from the University of Munich, and what they do, they build a web services where they compare different farming solutions. In that case, it was they started with farm management systems and just make comparisons. What does solution one offer compared to B, to C, to D, so that a farmer gets a kind of pre-selection and some support. I think such a service is very, very helpful for farmers.
Perfect. Thanks for the answer, Gunter. I'm sure more people have answers to this, but what I might do first, Jorge, is pass over to you. So Jorge is our work package 6 lead, which handles the exploitation, communication, and standardization within Demeter. And he is going to speak about the next steps. And I think that will also involve the co-creation. So over to you, Jorge. Thanks very much.
Okay, thanks, Dave. Can you see my screen?
Yes.
Okay, so I am. My name is Jorge Lopez. I work in Atos, Spain. I am the exploitation manager, and I think I can skip the contents and go quickly through the contents. Our main announcement is that the first version of the co-creation application is already available for internal use, and also for you open call winners. You are invited to join this space. The short name of this application is SOX, and this application will enable, like I said just now, will enable farmers, software providers, advisors to collaborate, developing solutions, involving the farmer in all the processes. So it ensures that the farmer's needs are addressed. It's not the purpose now to make a demonstration or explain in detail SOX. I will just mention that you can find different sections, areas like the blog, wiki, a catalog of companies, farmers. And we hope that you can find a series of benefits, knowledge sharing, joint events, fun opportunities of customers, learn from innovative technologies. You are all welcome to join this space and this community. At this moment, you can position yourselves as early members in the community and network with other companies and hopefully improve your solutions. In order to join SOX, you only need to log in with your current account. I believe in the URL that you can see. I believe it's the same URL as the Digital Enabler Hub, only replace the word DEH with SOX. Then you request access to the developer's workspace. For that, you need to send an email to Francesca and Antonio at the emails that you can see here. And it's important that you check the user manual. It's very easy to find. Just type the words user manual in the search bar. It will be the first result. But you don't need to write this down. I think we will send you this information. And probably, I think we might publish a video explaining and demonstrating SOX, because we recorded an internal webinar explaining SOX last week. I think it could be an interesting resource and for potential users to learn more and quickly about this tool. Regarding the Digital Enabler Hub, which is another key component in our ecosystem, you already should know this application because you integrated your services and applications here in your project activity. You can expect from us to gradually register more the different pilot applications and resources that we generate in the project. All these components that we develop within Demeter should be available to Open Call winners. If you are interested in some resource, you can contact the corresponding owner. It should be no problem about that. Also, I remind you that you should provide maintenance service of your solution until April 2023, making sure that it is usable until that date. And the integration of SOX and the Digital Enabler Hub is the next logical step for us once we have tested each component individually. This integration will allow us to use the catalog to create a synergy between both applications, to use the catalogs of organizations, farms, and apps in the co-creation application, where the challenge of a farmer has been posted and connect with the resources in the catalog. And so it's important to this synergy to achieve the whole Demeter platform concept. So this feature should be rolled out gradually during this year. You are welcome to collaborate in this test. Like I said, you can position yourselves as early members in this community and hopefully improve your solutions. And finally, for the wider community of external developers, the project is still in progress developing, so companies interested should check back to the website and the newsletter, sign up for the newsletter, and to get more concrete information. As we develop our plans, we will at some point make announcements of the resources available in the future, our activities, campaigns to engage all stakeholders. And this is the end of my presentation. Thanks to all OC winners for your interest, and we will keep in contact through all the channels that we have open. Maybe if there is some question after this presentation, we are late, but maybe we can take some minute if there is some question.
Yeah, I think, Jorge, we should probably leave it there. Thank you, everyone, for giving up your time this morning, to all our Open Call winners for presenting your solutions. It was really interesting to hear about how you address the Demeter Open Call challenge and how you're integrating with the Demeter technologies and ecosystem. Thank you to all our attendees. As Dave mentioned, if you have any questions that we haven't answered today, feel free to drop us an email. I've put the email address in the chat, and we will come back to you on that. As I mentioned at the beginning of the webinar, it has been recorded, so we will send you a copy of the recording, and we'll also send you a copy of the speaker slides this morning. And as Jorge said, please feel free to sign up to our newsletter to get up-to-date information about the activities going on within Demeter. So thank you again, everyone, for attending, and enjoy the rest of your day. Bye-bye.
Thank you.
Bye
Bye-bye.
bye.
Thank you. Bye-bye.
Thanks, bye.
Have a nice day. Bye.